Okay, thanks. This one is the first chapter of this class 12, and we are talking about today rotational dynamic. This is about how the any object or the particles when in the motion of the rotation, how it shows its nature. We are going to describe. How it is described here is one of the technique is also given here, so that the important thing is to know how the different particles motion we are going to take their motion into the account. This is our main importance in this chapter. First of all, in the class 11 or in the class 10 or in class 9 we described about the Newton's law of motion. That wasn't sufficient to describe the motion of a particle which is in the rotation, so that one of a new concept was introduced in the rotational dynamic. In order to describe the motion of a body, we have to use Newton's law of motion. But this Newton's law of motion, which we studied in class 9 or 10, that wasn't sufficient. That wasn't and this is not still possible to apply the Newton's law of motion to describe the motion of an individual particles of each and every individual particles. They are not described by the Newton's law of motion, so that there was a difficulties to describe the motion of the particles, and in order to get overcome from this difficulty, the concept of the rotational dynamic, that means concept of a center of a mass, was introduced, and which is now that has been introduced in this chapter. And this rotational dynamic depends on the center mass of a body. And what is center of a mass? Here is given. Center of a mass is defined as a point at which the mass of a body is supposed to be concentrated. Any particles, if you have these particles, mass is always concentrated at its center. It is the concept of a center of a mass, and the concept of a center of a mass enables us to treat any real object as a point object. Suppose you have a stone, and you can say the stone's whole mass is concentrated at the center of a stone. And the transitional motion can be described in 1 or 3 or 2 or 3 dimensions, but the rotational motion can either 2 or 3 dimensions we can describe them. So it is because to describe the rotational motion of object, at least 2 dimensions is required. We cannot describe this rotational dynamic like the way we have been describing the translational motion in 1, 2, 3 dimensional, and it must have 2 dimensions to get or to describe the motion of the rotational dynamic. Thank you.